ahead. So for Monday, what we're going to do is wrap up our notes, which is right here on angles of elevation and depression with our trigonometry stuff. So I'm going to actually move the calculator out of the way for now. So last week we dealt with all of our trigonometry for finding missing sides and missing angles. I want you to write that over here because it's a Monday that, come on, just a second. I've got it dead. Sorry if you're listening to the recording, my pens are activating. I shall get it going. All right, anyway, so we were dealing with our trigonometry. Go ahead and write SOHCAHTOA on the top of there because we've been using that a ton. Now I'm going to see if I can activate my pens here. If not, I might have to go to the whiteboard. There we go. All right, I've got it. So let's go on the top and write our relationships. Our sine is our opposite over hypotenuse. Then we have our cosine, and then we have our tangent that we're using to find all our missing sides and all our missing angles. We ended on Friday with word problems, and we're going to continue with those. The only difference is these word problems are called angle of elevation and depression. So it's things that are, you're either looking up to measure things. Sometimes when you're driving, do you ever see on the highway they have those, they use yellow tripods, and people are measuring things? Those are angle measurers. And so they're measuring tall things like trees and telephone poles and all of that fun stuff, cell phone towers. They're measuring them with a device that measures the angle. So what happens is this is called an angle of elevation when you're basically looking up at it. All right, so go ahead and, I don't know what's going on with my pen. Now it's working. So it's when you're looking up, and that's the angle of elevation. The angle of depression is basically when you're looking down. They're actually equal because, go ahead and drop your triangle thing down here. You've got the horizon, which is your eye level, and then you've also got, I don't know why my pen is being so weird, but luckily notes are short today. We've got ground level and we've got the horizon, and they run parallel to each other. And in another chapter, you learned that alternate interior angles are congruent. So if this guy is, I don't know, that looks like it's about 38 degrees, then you can hop in the triangle by saying this guy's 38 degrees. So when they give you an angle of depression, you're going to, I want you to draw an arrow, you're going to hop in down here because they're the same. Remember our alternate interior angles being the same from first semester, right? Some of you are nodding. That's what you're going to use. And then suppose you knew that this dog was looking up at an angle of 38 degrees, or you knew the bird was looking down. It doesn't really matter. And you were trying to measure the height of the, let's measure the height of the tree. Suppose they walked away, let's do 20 feet down here. And you're like, well, how high is the tree? In the real world, that's used to measure really tall things like mountains and tall buildings, cell phone towers, that kind of stuff. We're still going to do these the same way we did last week. We always had it across from the right angle. And so I'm doing a little review here. And we call that the hypotenuse. Bjorn, do you remember which one I'd have you do next after hypotenuse?
Opposite.
Opposite. That's across from the angle. And then the loner gets the adjacent side. Then last week we said, well, let's cross off that one we know absolutely nothing about. Has absolutely nothing with it, right, Isaiah? Which trig function would I use that deals with the opposite and the adjacent? Go ahead and tell me. Opposite and adjacent. Tangent. All right, so let's go set this one up. We would say the tangent of our angle, and it is opposite, that's the one we're looking for, over our adjacent, which is 20. And then, Logan, Kate, do you remember what to do next here? I'm just reviewing last week's just a... Yeah, multiply by the denominator, which in this case is a 20. So if you guys could take out your calculators, make sure, again, it's in degree mode. It looks like you just did it, Brandon. What'd you get for 20 times the tangent of 38 degrees? 15.6. So the height, can I get a backer on that? You're my first hour. So 15.6 feet would be the height of the tree without actually measuring the tree. One of my students in my next hour has, I think it's a brother or some relative who's a pilot who told him that he uses this quite a bit because you head in at angles, right? And you want to figure out where you need to land, to hit the runway, all that good stuff. That's trig. So let's go take a look at this one. It says a building is 20 feet tall. So when you do your homework, as usual, you know I'm going to ask you to draw a triangle. So I've got my building 20 feet high. You can make it a building if you want, but why not? I will. At a distance away from the building, an observer, okay, so I'm going to put my observer over here because I'm going to run into my pen tool, but so I'm going to put my observer right here, notices that the angle of elevation from the ground, so they're actually giving you this one. Angle of depression would be if there was like somebody on top of the building looking down. And they said that that's 31 degrees. So we're going to do 31 degrees. We're going to make our right triangle in there. And we're going to go through our whole process. Our goal is to figure out, so we need an X. How far is the observer from the base of the building? So let's go put an X on there. And then I'll have you guys help me talk it through. All right, Parker, which one do I label first on my blue triangle? Hypotenuse, always across from the right angle. And then Bjorn said we always do the opposite next, so let's go do that. The loner is the adjacent. And then, Nina, we're going to cross off the H because it doesn't have a partner. And then we have to decide which one of these we're going to use to figure out how far the observer is from the building. Which one would it be? This is tangent again. Actually, in the real world, tangent is the one that gets used the most because this is in the air, right? So it's kind of hard to measure that. It's usually in the air on something that's very, very, very tall. So tangent, honestly, is the real world winner most of the time. It's also used to find like pitches of roofs, like in building. Anyway, let's go set this one up. We have the tangent of our 31-degree angle is equal to the side opposite it, which is 20, over the side adjacent it. On the last one, Logan said to multiply by 20. On this one, Eve, what will I multiply by? X. We always multiply by that denominator. So I'm going to go like that. A little times X, a little times X. They will always cancel, right? And then, Cole, would I be done? No. What do I need to do before I can go to my calculator? Like, or what are you going to do on your calculator? Yeah, you're going to divide. And remember, this is a number right here, tangent of 31. Our calculator knows it, so we don't really need to write that number down. But if it bugs you, you could go tangent 31, write it down. You'll still need to divide by it. So if I could get a little help on what 20 divided by tangent 31 is, we will get the distance away from the building.
33.29.
Back around a 33.29, perfect. And it said to the nearest hundredth, so that's good. You have a test coming up on what day? Thursday. So make sure you don't lose little halvesies for not rounding correctly. So today is really the culmination of everything you've learned. The word problems that go with the trig that are dealing with real life, like elevations and depressions. So the next one up. You're 80 feet from a tree. All right, well, let's go get our tree here. And I am 80 feet away. The angle of elevation from your eyes, okay? So there's my eyes. Actually, I should put myself on the ground here. Here's my eyes. It says the angle of elevation from your eyes, which are 4.5 feet off the ground. I'm going to put a little 4.5 over there because I'm going to have to do a little problem solving here. To the top of the tree, so let's go like that, is 77. So actually I have to draw my right triangle like this, 77 degrees, because this is how tall I am. My angle starts at my eyes, not at the ground. So it says, how tall is the tree? Well, first of all, I would put an X. I'm going to go and grab that orange again. I would put an X right here. But then when I'm done with it, what am I going to have to do with it? What do you think? I'm going to find that X. But I'm 4.5. My eyes are at 4.5 feet already. I'm going to have to add it on. Yeah, so we'll have to add on that 4.5 feet because we're not starting at ground level with this problem. We're starting with the eyesight going up. But we still have an angle of elevation. Again, if there was like a bird on the top of this tree and it says the angle of depression, boom, you put your 77 there, but alternate interior there. You'd still work with the problem the same way. So let's go figure out what, this is another tangent problem, which I told you most of these are, because we are working with opposite and adjacent. So let's go, tangent of our angle is equal to opposite over adjacent, and then multiply by what's on the denominator, like you guys told me before, and then hop on our calculators. Lauren, could you do a little 80, tan, 77 for me? $300 or 200? 346 point what? 52. That's this distance right here. So then we're going to need to add on the 4.5 feet because it was from eye level. So what is that? 351.02 feet. That's it for today. We just wrapped up our trig chapter. So what you guys are going to do is, I'm going to give you a blank sheet of paper. You have 6 problems to do on Delta Math. When are they due? Today, right now. Like when you're done, they should go in here. Plenty of time. And then in Schoology, there's a formative quiz that I want you to do. It doesn't have any word problems in it. I just want to find anyone before the test who's still struggling with the special right triangles and or the trig. That's what it's on. I don't think I put it in the favorite theorem on there. I think we all had that down. So this one, there's 6 off of Delta Math. Just like last week, I need a picture. I need a trig setup. Let me know if it's not open. You're my first hour of this. Sometimes, oops, I'm going to stop recording too. And Asante,